Today's lesson is on to graph linear equations using intercepts and to write linear equations in standard form. Just a little refresher, the slope-intercept form of an equation is y equals mx plus b. M is equal to the slope, b is equal to our y-intercept. The point-slope form of an equation through a non-vertical line with the slope of m and through the point x1, y1 is as follows. Y minus y1 is equal to m times the quantity x minus x1. y1 is your y-coordinate, x1 is your x-coordinate, and m represents your slope. ax plus by equals c is another form of linear equation. It is also called your standard form. A and b cannot equal 0. And here's an example. 2x plus 3y equals negative 6. In order to graph equations in this form, you can use the x and y intercepts. You already know what the y-intercept is, the point where the graph crosses the y-axis. The x-intercept will be the point where the graph crosses the x-axis. Let's take a look at our example. 2x plus 3y equals negative 6. What did we determine was the x-coordinate always when we're looking for the y-intercept? And hopefully you said 0. Using that, we can determine what one of our intercepts is. And we're going to take x and substitute in 0 for it. So we have 2 times 0 plus 3y equals negative 6, which leaves us with 3y is equal to negative 6, and y is equal to negative 2. Divide each side by 3. That gives us one of our points at 0, negative 2. And using the same information, how can we find the x-intercept without changing the equation into slope-intercept form? And you want to think again. What will the y-coordinate be every time the line crosses the x-axis? And your answer again should be 0. So we're going to use that information, plug it back into our equation, except this time we're going to make y equal to 0. 2x equals negative 6. Divide each side by 2, and we get x is equal to negative 3. So our second point will be negative 3, 0. Here's our equation, once I move this. And you can easily graph it just by using the intercepts. Negative 3, 0, negative 3, 0, 0, negative 2. Plot your points and draw a line between the two of them. If a equals 0, you can write your equation as y equals b, where b is a constant. It's going to be any number, any fraction, positive or negative. Your graph will automatically form a horizontal line passing through whatever point y is equal to. If in standard form your b is equal to 0, that means you're going to write your equation as x equals b. Again, b is any number, fraction, decimal, negative, positive, integers, you name it. Your graph is going to form a vertical line passing through the point that's labeled as b. Sometimes our slope will be a fraction, and it's not always easy to work with them in standard form equations. So what we kind of have to do is get rid of them. And I know you guys love fraction work, so I'm going to try to make this painless. Here's an equation, y equals negative 3/5 x plus 4. How can we get rid of 5 in the denominator? Or for that fact, how can we get rid of any number that's in the denominator? You want to multiply both sides of the equation by whatever number is in the denominator. So in this case, we would multiply both sides by 5. And remember from your fraction work and distributive property, the 5 is going to get lost. It's going to go away because it will cancel out when we multiply this 5 times it. So we're going to be left with negative 3x. And then we have to distribute and share the 5 with the 4 as well. So we get negative 3x plus 20 on the right side. Left side just becomes 5 times y. We're going to add 3x to both sides. And now our equation is in standard form with integers only. 3x plus 5y equals 20. Another common form of or use for standard equations you'll see is word problems. Ryan has 2 part-time jobs. He can either make $12 an hour mowing lawns or $5 an hour delivering newspapers. Write and graph an equation to find the amount of time he must work at each job to make a total of $120. Well, the first thing we want to do is define our variables. C is going to equal his total earnings, M is going to equal mowing lawns, and D is going to equal delivering newspapers. So he gets $12 an hour mowing lawns, plus $5 an hour delivering newspapers, and that's going to equal his total amount of earnings. His total amount that he's looking to make is $120. So we're going to graph this using intercepts. The first thing we're going to do is substitute in 0 for the mowing the lawn hours, and then we're left with 5D equals 120. Divide each side by 5, and in order for him to earn $120, he's going to have to deliver newspapers for 24 hours. We also need to find out how much or how long it will take him to make $120 for mowing lawns. So this time we're going to substitute in 0 for delivering newspapers, 120 for how much he wants to earn, and we're going to solve the equation for M. And in this case, he'd have to mow the lawn for 10 hours to earn $120. Now we want to graph it. Here's our points that we got, 0, 24, and 10, 0. When you graph these, you need to make sure that you use the appropriate labels, not only for the sides here, but also when you number your axis. In this case, I numbered down here by 1s, and because our y value was 24, I numbered up here for every box was worth 5. Now we're going to plot our 2 points along the axis. 10, 0, 0, 24, and you're going to connect a line between the 2 of them. Notice that there is no arrows going, and it stops at the intercepts. That's because you can't work less than 0 hours. There's a limit on this. The nice part about this is when you look at this equation, any combination of hours mowing lawns plus delivering newspapers is going to earn him $120. So it's not just he has to work 10 hours mowing lawns and not deliver newspapers, or he has to deliver newspapers for 24 hours and not mow any lawns to earn $120. Any point that falls on this line and the combination of coordinates will tell you how long he has to work either mowing lawns and delivering newspapers to earn the $120.